So, hello guys, this is Dr. Edwards again. I want to give you now some suggestions from assignment number 5. These are the first set of exercise questions in chapter 11. And there are only 4 that I have listed. So let me get started with those. The first is number 1. State the 4 principal types of bonding in crystalline solids and give an example of each. Let me state that there are basically 2 types of solids that you encounter: crystalline solids and non-crystalline solids, or amorphous type material that you encounter, such as plastic and glass. Both of those are amorphous material. But crystalline solids, also called morphous material, have a periodic arrangement. And so I'll get to that in a moment. B, what is the fundamental physical origin of all of them? And C, what kind of particle is present in the crystal structure of each of them? Let me bring up the following to do that with. Let's see. Okay, so this table in your book summarizes everything that I wish to say about these crystalline type solids. There are only 4 kinds, and you need to know all 4 kinds. The covalent solids, and this is an illustration, there is a sharing between the atoms or the ions, in this case atoms most of the time. Where each represent a pair of electrons. Each slash line represents a pair of electrons, and the center white dots represents atoms. So that's the covalent kind of bonding, and that's a sharing phenomenon. The ionic, IONIC, is the second kind of bonding that occurs in crystals, and that is a situation where electrons are moved from the positive one atom and is joined with the a second atom. So here we have the case that the black dots, as shown here, are left positive charge because they have given up an electron to each of the white dots. This is the way that this type crystal holds itself together, and those are called ionic bonds. The third is metallic, metallic, metallic type crystalline solids. These are crystalline where the outermost electrons have been detached from the metal atoms, and the metal atoms have become ions, having a positive charge. And the very nature then of having these electrons intermingle amongst these positive charge ions allow for the material to bond together. And it's only the outer electrons, I emphasize, that are engaged in this process. The final is the molecular type bond, the molecular type crystalline solid. And in this phenomenon, what is happening is that each of the constituents are held together by dipoles. Effectively, one part becomes negatively charged, another positively charged, and in such, the system manifests a way of forming forces between the particles there, and as such, the crystal can exist. And these are called van der Waals type bonds. Part B, what is the fundamental physical origin of all of these? And the physical origin then is represented by the type bond. For the covalent, it's a sharing of electrons. For ionic, it's electron attraction between the negative and positive. Metallic is the sea of electrons that's been liberated from the atoms that allow the metal to bond as a crystalline solid. And lastly, then the van der Waals forces between these dipoles allow the material to exist. See, what is the kind of particles that's present for each of these? Here you will have diamond as an illustration for covalent, sodium chloride, an illustration of ionic, and copper, any of the metals, copper, gold, silver, platinum, etc., represents metallic. And ice, no less, young people, is a clear illustration of the molecular type bond. Okay, so I wanted to share that with you. Okay, let me go back to the questions now again. The second question now is number 2. What kind of solid is ice? And why does ice float when nearly all other solids sink when they freeze? As we just stated back in problem number 1, ice is referred to as a molecular solid, or some would even say a van der Waals solid. Either is okay with me. And it occurs with a dipole interaction is the way that material bonds itself together. And why does ice float? Ice float in water because when ice is formed to form the crystals, the particles have to push themselves further apart than what they were located relative to each other in the liquid state. As a result of pushing themselves further apart, the density of ice is less than the density of water. Therefore, ice will float in water because the density of it is less than that of water, and therefore the buoyant force on ice will be greater upward than the buoyant force of gravity pulling the ice down in water. So the density is what I will accept. The density difference between ice being having a smaller density than that of liquid water allows for ice to float in water. Number 3, are ionic or covalent crystals more common? Ionic crystals are more common than covalent crystals, and the primary reason is the tremendous amount of metals, and all metals then make stable ionic crystalline, even the element themselves, or even when the a metal is bonded in forming a compound, you have these metallic ions forming these ionic crystals. So there are so many more of them than non-metals until they are far more common. Number 3. Number 10, lastly, what ions would you expect to find in the crystalline structure of magnesium oxide and potassium sulfide? Okay, so you can think about this with the periodic table. I don't have it to show you right now, but you will find that magnesium is in the second column of the periodic table. So when magnesium bonds with some other substance, oxygen in this case, the magnesium will liberate or give up its 2 outer electrons in its outer shell, leaving the magnesium ion +2. And in turn, since the oxygen accepts the 2 electrons that magnesium liberated, then oxygen here is going to be an ion of -2. So then what type ions would you expect in magnesium oxide? You would expect +2 for magnesium and -2 for oxygen. In this particular substance, potassium sulfide, potassium then is in the first column. It is one of the alkali metals. And it will always liberate that one electron in its outer shell. Sulfur, which sits right under oxygen, will wish to receive 2 electrons. However, potassium only give up 1. But now notice there are 2 potassium atoms present here, K2. So 2 electrons are given up, and sulfur accept those 2. Therefore, what ions would you expect to find in these crystalline structures? You would expect to find positive 1 ions and negative 2 ions in this structure here of potassium sulfide. Okay, guys, wanted to share these with you. Compare what I have indicated here for my answers with your answers. Get your homework in as soon as you can for this section. Let me just remind you again that I tend to help you much of the time with these exercise questions. All of the multiple choice questions, I expect you to do them as well, turn them in as a separate assignment. Indicate to you one more time that the answers to all of the multiple choice questions are available. They are on a Blackboard under the place where you receive these questions, okay? Don't just go there and copy the answer. You need to understand why the answer is A, B, C, or D, E, etc. Okay? All right, guys, I'm gone. Have a good day.